Hello everybody. Today we're solving this paper, May-June 2020, paper 2-1. Okay. So this paper has been slightly tweaked so that it now follows the current syllabus, which is syllabus 2025. It's now 2 hours long and the total marks are 100. Okay. You should be able to view the paper and its marking scheme from the link below. You will find a formula sheet in the new papers. And here's the first question. Let's take a look. It says rectangle A measures 3 centimeter by 8 centimeter. 5 rectangles congruent to A are joined to make a shape. Work out the perimeter of this shape. Let's do that. So this side is going to be equals to this side. So this would be 8. This would be 8. Okay. And then this side is 3. So this would be 3, this would be 3, and we have 3's here, here, and here. Okay, this was 8. Okay, let's see what else. Okay, now we know that this would be 3 as well. So if that's 3, then 8 minus 3 is 5. So this should be 2.5, and this should be 2.5. So now these lengths are 2.5. These are all 2.5. And I also missed this. This would be 8 as well. Okay. Now let's find the perimeter. How many 8s do we have? 1, 2, 3, 4, 5, 6. 6 8s. Plus, how many 3's do we have? 1, 2, 3, 4, 5, 6. Plus, how many 2.5's do we have? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now you do not have a calculator, so this has to be done without a calculator. I hope you can do it. This is going to be 48 plus 18 plus what is going to be 2.5 times 8. So I know 2.5 plus 2.5. In fact, 4 2.5s make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 2.5 make a 10. So 8 2.5s would make a 20. Sum this, getting 86. Let's check the answer. 86 is correct. Okay, moving on. Find the highest odd number that is a factor of 60 and a factor of 9. Okay, so basically highest odd number that is a factor of both. Okay, so let's find the factor of 60 and 90. As soon as this lets me write. Okay, here we go. So factors of 60 are 2. I'm finding prime factors first. So 2, in fact, I think I can just do it otherwise. Okay, I know 2 is a factor of 60. I'm stating down all the factors of 60 and 80. So 2 and 30, then 3 and 20, then 4 and 4 ones 15, and then 5 and 12, then 6 and 10. I believe that is it. And for 90, it's going to be 2 and 45. I believe it's going to be 15 then, because 15 is a factor of 60 and 15 is also going to be a factor of 90. So the highest odd number that's a factor of 60 and 90 is 15. Yep, that can be seen here. So this would be 15. Because we know 15 is also a factor of 90. Okay. So Mrs. Salman gives her class 2 mathematical tests. The scatter diagram shows the information about the marks each student scored. Okay. Write down the highest marks scored in test 1. Okay, here's test 1. and I believe this cross represents the highest test score in test 1, and that seems to be 66. So is 66 the answer? Yes. Write down the type of correlation shown in the scatter diagram. Now, this is a rising curve or a rising line, so it's going to be positive correlation. Draw the line of best fit. So a line of best fit needs to be a line passing through these data points. So it is, in a way, a line of symmetry of this shape that we see, and it should pass through as many points as possible. Let me try drawing one. So what if you make a line like this? This looks like an appropriate line of best fit. Needs to pass through the center of the data approximately, and it needs to cut as many points as possible. And also it says that roughly it needs to have either same number of crosses on either side. Okay, so and it makes sure that you extend it throughout the graph. So it gets extended like this. Okay, line of best fit drawn. Hamish scored a mark of 40 on test 1. He was absent for test 2. Use your line of best fit to find an estimate for his marks on test 2. Okay, Hamish scored a mark of 40 on test 1. So let's see. This is 40. And when it touches the line of best fit, we get 48. So if he was absent on test 2, then it is estimated that he scored 48 in the second test, according to the line of best fit. That says any value between 46 to 50 is accepted. Okay. Moving on. A bag contains blue, red, and yellow, green balls only. A ball is taken from the bag at random. The table shows some information about probabilities. Complete the table. Okay, so the sum of all probabilities is always 1. So what we'll do is we'll do 1 minus add the remaining probabilities. This gives, should be a 0, 8, 0 0.78, and this would be 0 0.22. Yes, that is correct. Abdul takes a ball at random and replaces it in the bag. He does this 200 times. How many times he expects to take a red ball? Okay, so in such questions, when they use the word expects and they give you a number 200 times, you use the probability expectation equals NP. N is the number, and pre is the probability of the event mentioned. Abdul takes a ball at random, replaces it in the bag. How many times he expects to take a red ball? So what's the probability of getting a red ball? It was 0.2. So this becomes 200 into 2 by 10, 40. Okay. The nth term of a sequence is, let me check the answer first of 4b. It is 40. The nth term of a sequence is 60 minus 8n. Find the largest number of the sequence. Okay, so the largest number is going to be the smallest value of n, because as n becomes bigger, this value becomes smaller because it's being subtracted by 8n. So the lowest value n can take is 1. So 60 minus 8 times 1 is 52. Okay. Here are first 5 terms of a different sequence. Find an expression for the nth term of the sequence. Okay, so let's see what's going on here. This would be plus 7. This would be plus uh, 7. This is also plus 7, and this is also plus 7. So this is first level common difference. The formula for that is a plus d n minus 1. A is the first term, d is the common difference, times n minus 1. It's going to be 7n plus 5. That should be the answer. Yes, that is the answer. The diagram shows a trapezium. Work out the value of x. Okay. Now, if this is a trapezium and these two lines are parallel, then through interior angles, we know that the sum of these two angles would be equals to 180. So 97 minus 3x plus 69 plus 5x should be equals to 180. So 97 plus 69 minus 180, this you'll do without a calculator, and here we'll have 8x. I am using a calculator, but you will not. This gives us negative 14 is equals to 8x. Let me confirm. Did I mess up anywhere? Okay, looks good. So x is coming out to be a negative value. X comes out to be minus 14 by 8, which is minus 7 by 4. Let's check. That's actually supposed to be 7. Let me quickly find my mistake. Okay, here's my big fat blunder. This was supposed to be minus 3x plus 5x would be plus 2x. And when it goes to the other side, it would be minus 2x. So we have minus 2x here. And then when we divide minus 2 on both sides, we get a 7. So x is equals to 7. Use this information to write 438048 as product of its prime numbers. Okay, so we know that this value is a product of the other two values given, which we're writing as prime factorized form, that we're writing in factorized form. Okay, so now we just collect these together. It's going to be 2 power 5, 3 power 4, 13 squared. This is the answer in prime factorized form. Work out this without a calculator, of course. 3 2s are 6, plus 1, 7 upon 3, minus 7 upon 8. This is 7. Okay, times 6 upon 25. We'll have to make the denominators the same, so times 8 times 8 times 3 times 3. It's going to be 24. That is going to be 56. That's going to be 21 times 6 by 25. Okay, subtract 56 and 21, we get 5 here and 3, and 24 here, and 6 here, and 25 here. Cancel 1 and 4, and cancel 7 and 5. So we're getting 7 by 20. Let me check. Yes, that is correct. So 7 by 20 is the final answer. Okay, next is factorize completely. So we can take 7 common and a common. So we get 3a plus 4b. This is the factorized form. Yes, that is correct. Okay. Next is we can take 5 common, I believe. So 4x squared minus 9y squared. Now this is the identity a square minus b square, which is equals to a plus b, a minus b. But first make sure you write it as 2x whole squared minus 3y whole squared. So this would be 5, 2x minus 3y, 2x plus 3y. Okay. Next is points A, B, C, D, E, and F lie on a circle with center O. Find the values of x and y. Okay. First is angle at the center is twice the angle at the circumference. So all we have to do is 110 divided by 2, which is I believe 55. Let's check. Yes, it is correct. And for the second one, look, its angle in the same segment. Excuse me. Okay. How's it angles in the same segment from E and D? We have an angle being formed on, why won't you let me write? Okay, yes. So from E and D, we have an angle being formed on the circumference, which is 24. And from same E and D, we have another angle being formed on the circumference, which is Y. So then they must be equal. From angles in the same segment are equal. So this is 24 and that was 55. Next question is, the diagram shows the speed time graph for 90 seconds of a journey. Calculate the total distance traveled during the 90 seconds. Okay, distance traveled is the area under the graph. So I'm going to split, this is the area under the graph, which can be split into, this is a trapezium and a rectangle. You may split it into any two parts, but I'm using this. So for the rectangle, this would be 6 and this would be 90. So 6 times 90 plus for the trapezium it's half plus height. How much is the height? This is 6 units. From 6 to 12 it's 6 units times sum of parallel side. So this side is 90 and the other side starts from 30 goes till 90, so that's a 60. Okay. Now let's solve this. We have 0 here, 9, 6 are 54, so 540 plus 2 and 6 gets cancelled. We have a 3 here, and we have 0, and we have 150. So 3 times 150 is 450 plus 540, which gives 0, 9, 9, 990, which is correct. Okay, next question. Rationalize the denominator. So that's just 12 upon square root of 3. To rationalize this, that means we need to get rid of the third in the denominator. So we can do times square root of 3 and times square root of 3. Square root of 3 times square root of 3 becomes 3. Numerator is 12 square root of 3. Cancel 3 and 4 or 12. So we're left with 4 square root of 3. Remember this 3 and this 3, they do not cancel. Okay. Next is, let me check the answer. Yes, that is correct. Next is we have to square this. So I'm going to use a minus b whole square identity, which is a square minus 2ab plus b square. It's going to be 12 minus 2 times under root 12 times under root 3 plus b squared is going to be just 3 because the square and square root will cancel. Okay, so we have 12, 13, 14, 15 minus 2 times these two multiply. 12 times 3 would be 36, and we know square root of 36 is 6. So that's a 12, which gives us a 3. So 3 is the final answer. Okay. Next part is C lies on the circle with diameter AD. This is the diameter. Now, if this is the diameter, that means that angle subtended from diameter is always 90. So that's a 90-degree angle. Okay. C lies on circle with diameter AD. B lies on AC. And E lies on AD such that BE is parallel to CD. Okay. Now, if these two lines are parallel, that means we have corresponding angles being formed here, so the angle, this angle is also 90 from corresponding angles. Okay, and then we're given a couple of lengths and we have to find the radius of the circle. That means we need to find the diameter and then just half it. Okay, now how do we do that? Okay, so I will be using Pythagoras here to get this length. That is going to be 12 square plus 5 square square root. This gives 169, which is the square root of 13. So this part is 13. Okay, now I'm going to use the concept of similar triangles to get AD. Okay, so if these two triangles are similar, by the way, how do you know they're similar? Similar triangles have the same angles. So look at the triangles given to us. Okay, so this angle is the same in both the triangle, it's the common angle. And then this angle is 90 in both the triangles. And then hence the third angle, whatever that is going to be same in both the triangles. So they're actually similar triangles. Now, if they're similar, let me write that down. So if ABE triangle is similar to ACD, then AB over AC equals BE by CD is equals to AE by AD. Okay. So let's substitute the values that we have. We have AB, which is 12, upon AC, we don't know. Let's write AC, equals BE is 5, CD is 15, AE is, I believe, 13. Yeah, we just found it. And AD is the diameter. So let's call it X. Now we need to find the diameter and then we half it to get the radius. So we have 5x is equals to 13 times 15. Okay, now you cancel 5 and 15 to make the math a lot easier. It's going to be 3. So 3 times 13 is 39. And then we divide this with 2 for the radius. So that's going to be 19.5. Yeah, that is correct. So the radius is 19.5 centimeters. Okay. fx, gx, and gfg is given. Find the value of b. Okay. Now for fg, you have to put g in f. It's going to be f5x minus 4, which is going to be 4 times 5x minus 4 plus 3, and equated to 20x plus b. Now simplify the left-hand side. 20x minus 16 plus 3 equals 20x plus p. Cancels, we have minus 13 is equals to p. Let's check. Yes, that is right. Okay. In the next part, we have to find inverse of this. So we start with y equals 5x minus 1 upon 3. Next, we make x the subject. So 3y plus 1 over 5 equals x. I did it in one step. Now the answer would be this, but y gets replaced with x. So 3x plus 1 over 5 should be the answer. Yes, that is right. Next, it says find the range of fx when the domain is between minus 2 to 1. Okay, what was fx again? 4x plus 3. Okay, now when f is minus 2, what do we get? 4 times minus 2 is minus 8 plus 3 is minus 5. And f1 is 4 times 1 plus 3, 7. So you're going to write the range like this. Fx is between 7 and -5, but since there's an equals to sign here, you'll also write an equals to sign here. So range is between -5 to 7. Domain are the values of x, and range is the values of y, or fx. Question 15. PRQ are points on a circle. AB is tangent to the circle. Okay. If a tangent is mentioned, then there is I see an alternate segment theorem here. How does alternate segment theorem work? If you have a chord and a tangent connecting like this, and then you have an angle between them. So this angle is equals to, just a second. It's equals to the angle in the opposite segment. So this would be x, which was not shown in the figure, so that got me slightly confused. Let me repeat alternate segment theorem for you. So let's say there's a chord and there's a tangent and then there's an angle given, let's call it x. This x is equals to the angle that is formed on the circumference on the opposite side, this one. So this is alternate segment theorem. Okay, according to the alternate segment theorem, this would be x. Oh, no, definitely not that. I'm so sorry. This would be x. If you form an angle from these 2 points of the same chord, this would be x. Okay, so anyway, back to the question. P, R, Q are points on the circle. AB is tangent to the circle at Q. QR bisects the angle PQB. Okay, so QR bisects the angle. That means it cuts it into 2 equal parts. So that means this is also x. This is x because of angle bisector. This is x because of alternate segment theorem. Use this information to show that triangle PQR is isosceles. Give geometric reason for each of your answers. Okay, so the geometrical reason is that PQR equals x because that's given in the question that QR bisects angle PQB, because QR bisects angle PQB, and also angle P or QPR. Angle QPR, this is also supposed to be angle. Angle QPR is also x because of alternate segment theorem. So since two angles are equal, it's an isosceles triangle. Let me just see the reasoning mentioned here. Okay, it also, you need to prove that it's not equilateral either. So if you don't prove that, you are 1 mark short of the full marks given in the question. Okay. So how do we prove, sorry about that, how do we prove that's not an equilateral triangle? Let's take a look. Oops. Yeah. So we are told that these angles are less, x is less than 60. So if x is less than 60, this is less than 60, this is less than 60, then this can't be less than 60 either, because angles in the three angles in a triangle sum up to be 180. So let's say if this is 59 and this is 59, this can't be 59 because then they don't sum up to 180. It has to be bigger value than 59 so that the sum of the three angles is 180. 180. I might have said 150 earlier. Okay, so you write that reason that since x is less than 60, R, angle R cannot be 60, cannot be x, hence not equilateral but isosceles. But isosceles. Okay, moving on. M is inversely proportional to the square of p minus 1. M is inversely proportional to the square of p minus 1. That gets replaced with m is equals to k upon p minus 1 whole squared. Now m is 5 and p is 4. So we're going to get 4 minus 1, which is 3. 3 squared is 9. K is equals to 45. So rewrite the equation m is equals to 45 over p minus 1 squared. Find m when p is 6. So m is equals to 45 upon, when p is 6, p minus 1 is 5. 5 squared is 25. Cancel it with a 5, we get a 9 in the numerator and 5. 9 over 5 is the answer, which is written as a mixed number. You may also leave it as 9 by 5, but it's always better to write it in mixed form. So 1 whole 4 over 5. Okay. Part 1 is find 3m. This is vectors. So that would simply be 15 and 21. VW is 12 minus 8. Find the magnitude of VW. So it's going to be square root 12 square plus minus 8 whole square. 144 plus 64. That gives 8, 198 square root. And now we simplify it because it says give your answer in simplest third form. Okay, I think I've messed up somewhere. It's not 198. It's 208. Okay, now let's do prime factorization of 208. We get 2, 104, 252, 226, 213, and then 13, 1. So we have 2 times 2 times 2 times 2 times 13. So the pair comes out as a single 2, this pair comes out as a single 2, and square root of 13 has no pair. So 4 square root of 13 seems to be the answer. Let's check. Yes, it is. Okay. Moving on. OABC is a parallelogram. Parallelogram means that the opposite vectors are equal as well as parallel. So this will be P upwards, this will be Q rightwards. So OABC is a parallelogram. OA is P, OC is Q. E is the point on AB such that AE upon EB equals 3 upon 1. Okay, so that means that AE has 3 parts and EB has 1 part. So that means in total this has 4 parts. So that means in total this has 4 parts as well. So this has 4 parts. So 4 parts represents Q, and then this has 3 parts. So 3 parts represents X. So X is equals to, in fact, 4X is equals to 3Q, and X is equals to 3 by 4Q. You can also do this directly without having to cross multiply. Full line has 4 parts, and A to E has 3 parts. So we write 3 by 4Q, and similarly this will be 1 by 4Q. Okay. We need to find OE in terms of P and Q. So for OE, go from O to A and O to E, A to E, sorry. So P plus 3 by 4Q should be the answer. P is equals to 2 times W plus H. 12, W is 12, correct to the nearest whole number. Nearest whole number means 1. And then you have to split it into 2 parts. That's 0.5. That means 12 in upper bound would be 12.5. And 12 in lower bound would be 11.5. And H is equals to 4, correct to the nearest whole number as well. That means 4 plus half would be 4.5. 4 minus half would be 3.5. Work out the upper bound value for P. So if we need the upper value, we're going to use upper W, which is 12.5, plus upper H, which is 4.5. So 12, 13, 14, 15, 16, 17. 17 times 2. 2 sevens are 14. 2 ones are 2, 3, 34 seems to be the answer. Let's check. Yes, that is right. Question 19. The diagram shows a cuboid of length 5, width under root 23. The volume of the cuboid is this, square root of 2900. By the way, this question looks odd because we have edited every question so that it now uh, fills up the criteria of syllabus 2025. Earlier, these questions could not be done without the calculator. They have been slightly tweaked so that paper 2 is now completely a non-calculator paper. That's why the editing is, mashallah, so off. Anyway, so back to the question. Volume is given square root of 9200 and find the angle between AG and the base of the cuboid. So AG is this diagonal, and for the base of the cuboid, you're going to make an imaginary line connecting A with the diagonal of the base, and we need this angle. Okay, let's see, what do we have? We can find the height of the cuboid using the formula for volume. Volume is given, which is base times length times width times height. So times x. So this would be 9200 upon 5 times square root of 23 equals x. Okay. Now I'm going to simplify 9200. Prime factorization 2, 4 here, 6 here, 00. Another 2, 2, 3, 00. Another 2, 1, 1, 50. Oh my god, that's a lot of 2's. Another 2, 5, 7, 5, then a 5. Let me check this with the calculator in case I mess up somewhere. Okay, so 9200 divided by 2 is right, divided by 2 is right, divided by 2 is right, divided by 2 is right. Okay, next we divide this with 5. So 5 ones are 5, again 5 ones are 5, 6, 7, 2 is carried forward, and 5 divided by 25 is 5. This again gets divided by 5, 2 and 1, 23. And then 23 is left. Okay, thank God. We have a pair which comes out. So the 2 comes out, another pair, it comes out, another pair, it comes out, and 23 does not have a pair, it stays inside. And then we have 5 times square root of 23. Cancels, 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 cancels. So we have 4 as this length. GC is 4. Okay. Now we need to find the angle between AG and the base of the cuboid. So that's the shape that we've already made, the theta that I've already shown. Let me clear this. So we know that this is 4. Okay, now I'm going to use Pythagoras theorem to get AC. That's 5 and that's square root of 23. So AC is going to be square root 5 square plus square root of 23 whole squared. That's 25 plus 23. That's square root of 48. Okay, now can we simplify square root of 48? Let's do that. 48 divided by 2 is 24. Divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. So square root of 48 is actually, this pair comes out, this pair comes out. So there's a 2 out, there's another 2 out, but 3 cannot come out. So it's 4 square root of 3. Okay, we're still not done. That's a lengthy question. Okay, so we now know that AC is what, and we already know GC is 4. Let me draw the triangle again. So the triangle looks something like this if we slightly rotate it. This is 4, and the length AC just came out to be 4 square root of 3. Okay, now we need this angle. So we're going to use 2 tan theta equals 4 upon 4 square root of 3. That's tan theta equals 1 upon under root 3. Now remember, this is the new syllabus, and exact trigonometric functions is part of your syllabus. So you need to know tan inverse of 1 over 3. Now for that, you need to either memorize the table of exact trigonometric values. You can Google it and note it down somewhere. That way you'll know that, let me check from my calculator, what is tan inverse 1 over 3, because I don't remember the table honestly. So tan inverse 1 over 3 would be, calculator should be in degrees. It is, sorry, it's 1 upon under root 3. So tan inverse 1 upon under root 3 is equals to 30, but we're going to use the longer approach to remember the tan inverse of 1 over under root 3. That is that you take an equilateral triangle, this is 60, this is 60, and that's 60 as well, but then you cut that 60 into equal parts, get a right angle here, so this is a 30. So next, every side you'll mark 2, 2, and this is also 2 because it's equilateral triangle, but then this becomes 1 and 1. Okay. Now, from Pythagoras theorem, I'm going to do 2 square equals 1 square plus this length square. Let's call it x square. So that becomes 4 minus 1, which is 3 equals x square, which gives us under root 3 equals x. So this would be under root 3. Okay. Now I know that if I need 1 over 3, that's tan 30 is equals to opposite over adjacent. So then this must be equals to 30. Otherwise, you can just memorize the table if you're not uh, cool with remembering this triangle. Okay. So, and if this topic is confusing you, you need to YouTube finding exact trigonometric values and look up that video. Okay, question 19. The curve y equals x square minus 2x plus 1 is drawn on a grid. A line is drawn on the same grid. The points of intersection of the line and the curve are used to solve this equation. Find the equation in terms of y is equals to mx plus c. Okay, now what do you do here? That you try to equate these equations. So we can take x square common in both of them, or make x square the subject. This becomes x, y plus 2x minus 1 equals x squared. This becomes x squared is equals to 7x minus 5. Okay, so now we equate them. Y plus 2x minus 1 equals 7x minus 5. Y equals 5x minus 4 should be the answer. Yes, that is correct. Now we need to expand this. So what I'll do, I'll expand the last two equations first and then multiply it with the first equation. So it becomes 3x squared minus x minus 15x plus 5, x plus 3. This gives 3x squared minus 14x plus 5. Okay. Now again, sorry, it's minus 16x, not 14, because minus x minus 15 is minus 16. Plus 5. Now we multiply these brackets again, so we get 3x cubed minus 16x squared plus 5x plus 9x squared minus what is 16 times 3? 48 plus 15. Can't believe I used a calculator there by mistake. You cannot use a calculator in paper 2 anymore. Okay, now this would be 3x cubed minus 5x squared, then minus 43 x, and then a plus 15. If I did not blunder, this should be the answer. 3x cubed minus 7x squared. Oh, there's a mistake. Minus 43x plus 15. So he messed up somewhere over here. How? Oh, minus 19, minus 16 plus 9 is going to be minus 7, not minus 5. So minus 7x squared, that was a blunder. Okay, rest is correct. Are we almost done? Find the area of a hexagon, regular hexagon with side length 8. Give your answer in third form. Okay, let me draw a regular hexagon. 1, 2, 3, 4, 5, 6. This is a hexagon. This is 8, 8, 8, 8, 8, 8. If it's a regular hexagon, then these lengths are equal to each other. This is equals to this, 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 this. Okay, the sum of these angles would be 360 because they're originating from a point 360, and I'm going to divide it with 6. That's going to give me 60 degrees. So if this is 60, all of these would be 60 as well. But if an angle is 60 and these two sides are equal, then these two angles must be equal as well, right, from isosceles triangle. But if this is 60, then that makes this 60 and this 60 as well. Because you'll do 180 minus 60 divided by 2, that's 60 again. So actually, all these triangles are little equilateral triangles. So that means all angles are 60 and also all lengths are 8. So the triangle become 8 times 8 times 8. Each side is 60. 60, 60. What do we have to do? We have to find area of one of these triangles and then divide it with 6. The area is going to be half times the lengths of two sides times sine of the angle in the middle. Okay, now again we need sine 60, that too without a calculator. So I'm going to quickly, in a rush, draw the same triangle again. This was 60, 60. The upper one was 60, but we split it into 2 to get a right angle. So this is 30. This side is represented by 2, 2, and this big side is 2, but now it's 1 and 1. Okay, and we had already seen this side would be under root 3 from 2 square minus 1 square whole under root. And now I need sine 60. So opposite over hypotenuse. So sine 60 is under root 3 upon 2. Let me confirm from my calculator. Sine 60 is, yes, just that. So it's going to be 6 times half times 8 times 8 times under root 3 upon 2. Now let's see what get cancelled. We can cancel this and this. This becomes 4. Then I'm going to cancel this and this. This becomes 4. So I have 6 times 4 times 4 times under root 3. Okay, 4 times 4 is 16. 16 times 6 would be 36. 6 1 is 6, 7, 8, 9. It's going to be 96 under root 3. Is that right? It is. Thankfully. Okay. Next is a question on sets. X is an integer and the universal set is between 41 to 50. So 41, 42, 43, all the way till 50. Okay, X is an odd number. So odd number within this region would be 41, 43, 45, 47, and 49. And X such that X is a multiple of 3. Multiples of 3 in this region would be 42 and 45 and 48. Okay, and then prime numbers in this region would be, is 41 a prime number? I believe it is. 42 is not, because that is 7 times 6. Okay, so 43, is 43 a prime number? I think so. 44 is not, 45 is not, 46 is not, 47, I believe is a prime number. 48 is not, 49 is not, and 50 is not. So these are the 3 prime numbers that I'm getting. I hope I have not messed this up. Okay, now complete the Venn diagram. Okay, so A has all the odd numbers. Let's first look for common numbers. Do we have anything that's common between all 3 of them? Actually, we do not. So there's nothing here. Let me check in the answer. Yep, there's nothing in the middle. Okay, now let's see what else is common. There is 45 common in these two, in A and B. So I'm going to write 45 here. So 45 is already written. Let me cut that out. What else is common? We have 41 common in these two as well. So 41 is common in A and C. So we have a 41 here. Cut this out. Then we have 43 common in A and C again. So write 43 here. Okay, anything else that's common? Yeah, there's 47 common in A and C. So 47 here as well. Okay, and next, this 48 is not common, so we write it here. Cut it out. The 49 is not common with anything, we write it in A. And then there was a 42 left in B, so there's also a 42 here. Let me check if I got this right. But again, the missing numbers have to be written in the correct regions as well. Let's see. 49 is already written. Now whatever is left comes outside of these 3 circles. So 41 is done, 42 is done, 43 is done, 44 is not done, 45 is done, 46 is not done, 47, 48, 49 is done, 50 is not done. So these 3 numbers are outside. Let me check. 44, 46, 50 is outside. 41, 47, 43 is where it's supposed to be. 49, 45, 48, and 42. Yeah, everything looks good. Okay, list the elements of A intersection C. Okay, so A intersection C is this region which has 3 elements, which we write it in set form: 41, 43, 47. Okay, next we need B union C complement. This is B union C. Complement means everything outside of it. So that are 4 numbers: 44, 46, 50, and 49. So write it in set: 44, 46, what was there? 49 and 50. Let me check the answer as well. 44, 46, 49. Okay, they did not write it as a set. That means writing it as a set is not a compulsion, because they did not mention write the set A intersection B. They just said write the elements of A intersection B. So those curly brackets outside are not a compulsion. Okay, find the number of elements in A intersection B intersection C. That is this region. There is nothing here. So that's going to be 0 elements. So it should be 0. Done. And how many questions are left? Honestly, 100 mark P2, we're not used to it. Earlier it used to be 70 mark, and before you would know it, it would be over. But now it's like a struggle to finish, especially when you're recording a video. It's definitely not a struggle to finish if you're just like working on it, especially by taking some breaks in between. But in a go in one video, it's difficult. Anyway, pretty sure you don't need to hear that. Okay, draw the image of triangle T after a reflection on line y is equals to -1. Okay, this line is y is equals to -1. I'm going to reflect this triangle on this line. Okay, so this is 3 units down. It goes 3 units up here. This was 4 units down, 1, 2, 3, 4. It goes 4 up. and this is 1, 2, 1, 2, 3, 4 down, 1, 2, 3, 4 up. So this is the image after reflection on line y is equals to -1. Okay, let me label it part A, although the question did not ask for it. Okay. Draw the image of T after rotation of 90 degree clockwise about 0, 0. Okay. So T has to be rotated 90 degree clockwise about 0, 0. 90 degree clockwise means that's coming in this direction. I would strongly recommend you do this with a tracing paper. Learn how to do this with a tracing paper. I'm going to attach a video in the description that teaches you how to rotate a triangle using tracing paper, and also how to find center of rotation using tracing paper. So I'm just for now going to write down the answer given. It's 1, 1, 1, 4, 2, 4. 1, 1, 1, 4, and 2, 4. This should be it. I'm making a dotted one. You'll make a solid one. Also, let me quickly check if the last one is right. -4, -4. No, that's not right. How did I mess up? Y equals -1 is the right line. Draw the image of triangle T after reflection on line y is equals to -1. Let me pause and check. Oh my God, I was supposed to reflect T. I was not supposed to reflect A. I cannot believe I blundered like that. Actually, I can believe I blundered like that. Anyway, let's quickly fix that. This is the answer for part B. And for part A, I'm going to do that in a second. So 2 units down like this, then like this, and then like this. This is the answer for part A, and that's the answer for part B. Okay, so that's done. Describe fully a single transformation that maps T onto A. Okay, how did T become A? It's obviously a translation because it's just moving certain units right and certain units down. So you write translation by how many units right is it going? 1, 2, 3, 4, 5. So write 5 right and 1, 2, 3, 4, 5, 6, 6 down. Down is represented by -6, or minus. Up is represented by plus. Right is represented by 5. Left is represented by 4. So this is 5 comma -6. Okay, that's done. Remember to look up rotation using tracing paper. Okay, find the value of S when U is equals to 5.2, T is equals to 7, and A is equals to 4. Okay, interesting. Without a calculator, let's check. 7 squared. Okay, 5.2 into 7. Let me do that on the side. So I'm going to do 52 times 7, 7 times 2, 14, 7 times 5, 35. That's 36. So we get 36.4 here. Okay, plus, I'm going to cancel this and this. We get 2. That's 49 doubled. That's going to be 98, I believe. Plus 98. Now add these up. 0.4 and then 8 and 6 gets added. 8, that gives us a 14. 1 carried. 9, 10, 11, 12, 13. I'm getting 134.4, which is right. Okay. Simplify this. So I'm going to swap the places of -a and -5b to make factorization possible. I'm going to take a common, 3 minus, okay, we're not supposed to do that. We're supposed to add and subtract the like terms. I'm sorry about that. It says simplify. It does not say factorize. Anyway, that would give us 2a minus 3b, and that's it. Okay, next up is multiply these two fractions. X and x cancels out, and 9 and 3 cancels out. We have 1 here, 3 here, and then 5 and 20 cancels out, 1 here, 4 here. Answer should be 3 upon 4. Let's check. Yes. Then we have to solve this. Easy peasy. 15 Divide by minus 3 equals x, x equals minus 5. Then we expand and solve this. 4 5s are 20, minus 12x equals 23. Move it around, we get minus 3 here and 12x here, and then minus 3 upon 12 is equals to x. X is minus 1 upon 4. Okay, and almost about to finish. Okay, simplify this. It's 27 x power 9 whole power 2 over 3. This means cube root of 27. Cube root of 27 is 3, and this means square of it. So 3 square would be 9. So let me repeat that. First you cube root 27, that gives you a 3. Then you square the 3, you get a 9. Okay, with this one, you just multiply 9 times 2 over 3. That gives us a 6. So 9 x power 6 should be the answer, which it is. Okay, next is expand and simplify. So we just open the brackets. We get 6x squared plus 3xy minus 10xy minus 5y squared. Simplified, this gives us 3x squared minus 7xy minus 5y squared. Let's check. That is correct, and that brings us to the end of the paper. I'll see you next time with another paper. Take care.